ignore what's on the screen.
I'm still going to go 36.8. All right, so the question is, I'm launching this from a 40-meter tall cliff from the edge at 50 meters per second, 36.8 degrees. This will look very similar to something you've seen before. This is what we're trying to find, R. So I had, so what do we know?
For J, or for the J to X, I hat is R, and then J hat is negative 40 meters.
Right, because it ends up 40 meters below from where it started, and I said up was positive. All right, what else do we know?
Acceleration is 0 meters per second, I had, and negative 10 meters per second, J had.
And, all right, so that's all we can pull straight out of it. We have to do a little bit of math to get the last two bits. I know my initial velocity is 50 meters per second at this angle, but I need to put it in terms of I hat, J hat. So 50 meters per second times the cosine of 36.8 degrees, I hat, plus 50 meters per second times the sine of 36.8 degrees, J hat. And we should end up with somewhere around 40 meters per second I hat plus 30 meters per second J hat. Because I chose that angle because the cosine of that angle is about 0.8 and the sine is about 0.6, unless of course I'm just on a roll and I've got that backwards. I see you tapping away, Stone. Is it 40 and 30 the way I claim? Oh, you're working on something else?
Oh, shoot, I just added them together.
Yeah, the cosine is 40.036568.
Okay.
Yeah, 40,
It was like 29.9 something.
yeah, just.
All right, 40 and 30.
I don't know why I just added.
So we need to find time. Which equation of the ones listed over there in green, which equation do we use in order to find the time? Because remember, it's the vertical that determines the time. We use that information to find time.
The fourth one is the one we used.
All right. So plugging into the fourth one, I have negative 40 equals 30t plus 1/2 negative 10t squared. Plug it into the fourth equation there, or negative 40 is equal to 30t minus 5t squared. Since we are using the vertical displacement, the vertical initial velocity, we're using the vertical acceleration.
There might be a problem because when we did it last time, we distributed a 5 out of everything.
In this
Should we
case,
try
we
doing
can, in
it?
fact, we can divide everything by 5.
Should we try doing it without? Maybe that was where the error came from.
Well, we should get negative 8 is equal to 6t minus t squared. Is that what we had last time?
Yes.
Mm-hmm.
Okay, I'm still feeling good with that.
The last time.
That's what we did last time.
Well, however, we got some other things last time which weren't true, but dividing everything by 5, there's nothing wrong with that
Well,
math.
shouldn't it be No.
You were thinking divide by -5?
Yeah, because of the -10, but that's not the same.
So at this point, it's a quadratic equation. How do I solve what's the simplest way to solve a quadratic equation?
Set it to 0, use the quadratic formula.
Years ago, I was tutoring a student in Algebra 2 or 3, whatever he was in. And he would complete the square every single time. In essence, driving the quadratic formula every single time. It's legitimate math. T squared minus 6t minus 8 equals 0. This will not factor nicely, so that t is equal to 6 plus or minus the square root of 36 minus 4 times 1 times -8, all over 2. That 36 comes from b squared, it's -6 squared, which is 36. I immediately have a negative sign there. So I get 6 plus or minus the square root of 36 plus 32 divided by 2, which is 6 plus or minus the square root of 68 divided by 2.
I just got 7.12.
That's 7.12.
I think so.
-1.12.
The average of these two should be 3, because if I just do the first part, ignore the radical, that should tell me the middle. So add those, divide by 2, I indeed get 3. So that part seems legitimate. Anyone else get 7.12 and -1.12?
Yes.
Okay.
It's now 284.8 for the.
Oh. So as we discussed yesterday, the math problem is I've got a set of axes here, I have axes here, I have basically the j hat position and time, and that's the plot where we're trying to find the zeros. Since we're initially throwing it upwards, I would expect there to be a positive and negative solution, where the magnitude of the positive solution is bigger than the magnitude of the negative solution, as discussed yesterday. So we have these two times, apparently slightly different than what we had before, for whatever reason. So now we know that this is 7.12 seconds. 7.12 seconds. And so now we can solve for R. Which equation do we use? Which equation?
Didn't we use the fourth one last time?
Yep. And we used it this time. Because I don't know VF, probably using the equation that doesn't have VF in it makes the most sense, which is this one. Because I'm now plugging in horizontal information, I'll use my initial velocity as the horizontal initial velocity. The acceleration is the horizontal acceleration, despite what some people might have claimed yesterday. So plugging into that fourth equation, we end up with R is equal to 40 times 7.12 plus 1/2 times 0 times 7.12 squared. That term goes away, just a classic distance equals rate times time kind of problem. And it was
284.8.
units.
Meters.
questions up to here? I know what you're thinking. You're thinking, hey, that was great, a lot of fun, but could you make it harder? Yes, let's make it harder. So what I'm gonna do is I'm gonna change this problem slightly. I'm gonna say that the R here, assuming that there's no careless error, is 284.8 meters. And try to find the angle. We'll be working backwards. There will be two solutions. And so, unless I just picked a very unfortunate set of numbers. So this will be 284.8 meters. This will be 50 times the cosine of whatever the angle is, and this will be 50 times the sine of that angle. It should have a sense of deja vu about it. If we plug into that fourth formula yet again, we have, plugging in the horizontal, 284.8 equals 50 cosine of theta times time, and negative 40 is equal to 50 sine of theta times time, plus 1/2 negative 10 t squared. Technically, there's a plus 1/2 0 t squared here, but that, the math people tell me that if you multiply by 0, you get 0. And I'm going to believe them on this. Solving for time in the first equation, because again, two equations, two unknowns. I have time is equal to 284.8 divided by 50 cosine of theta.
Sorry, I left my notebook.
Okay. Plug that into here. I get negative 40 is equal to 50 sine of theta times 284.8 over 50 cosine of theta minus 5 times 284.8 over 50 cosine of theta squared. No doubt bringing back some fond memories from 30 minutes ago.
Feels just like yesterday.
What's that?
Feels just like yesterday.
That's probably because you were working on these problems yesterday. As I assume everyone was. All right, let's get rid of some stuff. The 50 and the 50 cancel out. I'm left with sine over cosine, which is tangent. And over here, I've got that thing squared times 5. And I'm left with negative 40 equals 284.8 tangent of theta minus and this,
162.22.
that's after multiplying by 5?
Yeah.
Okay, and you said 160
2.22.
times over cosine squared theta, which all of us know is the same as secant squared theta. So negative 40 equals 284.81 tangent of theta minus 162.22 secant squared theta. Doing that trig substitution that everybody knows and loves, we all know that the tangent squared theta plus 1 is equal to the secant squared theta. So I'll plug that into here. Negative 40 equals 284.81 tangent of theta minus 162.22 tan squared theta plus 1. I don't feel like writing tan theta anymore, so I'm going to make a substitution. And I do this in a number of my videos, especially with sine and cosine. The more I write, the more chances I have of making an error. So I'm just going to let m equal tangent of theta. And I'm left with negative 40 equals 284.81 m minus 162.22 m squared minus 162.22. It is a quadratic equation. Time for a little quadratic formula. And I've run out of space here, so I need a new page. So I got negative 40 equals 284.8. 34.81. Where'd the 1 come from? 284.8 m. Come on. 162.22 minus 162.22 m squared minus 162.22. All right. I had 284.81 written down, and I'm not quite sure why on earth that would happen. So, getting everything over onto the left side, 162.22 m squared minus 284.8 m plus 122.22. Add that, subtracting 40. Okay. M equals 284.8 plus or minus the square root of 284.8 squared minus 4 times 162.22 times 122.22.
Shouldn't it be negative 122? Because even if you add 40, never mind, I forgot you do it backwards.
This time it's going to work. And the answers are .744. Yes. All right. Ideally, it'd be 0.75, but you know, our that 40 and the 30 were rounded. All right. So remember, that is solving for m. M is the tangent of theta. Ultimately, we need to know what theta is. So the tangent of theta equals 0.744. Or the tangent of theta is equal to 1.009. So now theta would be the arctan of 0.744, which should be about what we had the first time we did the problem.
and theta is equal to the arctan of 1.009. And so our two answers are glad we didn't do the brutal method and come out with the wrong answer the first time. At least this is the simpler of the two.
I use 0.7469, but, it's 36.756. And then
Degrees.
degrees, yeah.
For the second one, I got 0.78987.
Might be in
Which is,
I was in there when I was in ratings. 45.
256%.
degrees. So what we're saying here is that, yes, we got the answer pretty darn close to what we had the first time, that this would land right there, but there's another angle which is steeper, which is gonna go up and then land there also. We did not do this explicitly, but if I wanted the ball to land at the base of the cliff, there are two angles that I could throw it, in which it would do that. I could throw it straight up, which would go up and then straight down, or I could throw it straight down. There are two angles that would hit that. If one of those answers for M had been negative, what would that mean? Okay, I thought you were about to say something.
Well, negative.
It would have been
Angle.
turned straight down.
Or that, not necessarily down that way, but
Yeah.
yeah, somewhere down there. So if we've gotten a negative tangent, that it would have been thrown down here. All right, so bad news, good news.